of all, let me please introduce. Sorry about that. So this is Sebastian Goasguen. Okay, he's from Switzerland. He's a Citrix employee. Do you know Citrix? Yes. How many people know Citrix? So for
everybody.
Almost everybody. For who doesn't know Citrix and what Citrix does virtualization and cloud, right?
Yeah.
And some other stuff. So basically, they wrote Xen hypervisor, and they also developed CloudStack, which is a cloud solution, and they released it to Apache Software Foundation, right? And I will let Sebastian tell you more about it. So please welcome Sebastian.
Cool. Thanks a lot. Thanks, guys, and thanks to Adobe for having us tonight. I'm actually French, but I live in Switzerland. My name means white man, Goasguen. It's from Brittany. It's a dialect. So, you know, I'm not Swiss. I'm going to talk about CloudStack and big data. So actually, you know, when I talked to Andre and Eugene about it, I sent them an abstract and said, okay, great. But in fact, I just realized that he didn't read the abstract. So he doesn't know what I'm going to talk about. And he's like, oh, you should talk about something else. Okay. No, but, you know, I'm going to talk about CloudStack and big data because those are, you know, two of the biggest, you know, trends out there. You can find me on Twitter @SebGoa, and then, you know, LinkedIn and all those social things. I'm an Apache committer for CloudStack. I'm a member of the PMC, Program Management Committee of CloudStack. And before that, I used to be in academia doing R&D. So, you know, if you look at Google Trends, I like to keep an eye on the Google Trends because they, you know, they really show us, you know, what people are looking for and what technologies are really peaking out there. So what we see here is the, you know, the graph of Google Trends. It's a little bit dated. It's probably mid last year, mid 2012. I wanted to plot grid computing, which was what I was working on, and that you see in blue here, and it's clearly going down. The virtualization, which is, you know, relatively flat throughout the years. Cloud computing in red, you know, has really started in 2007. And now you see that it's plateauing a little bit since, you know, beginning 2011. And what you see in green, you know, at the you know, bottom right corner is big data. So big data starting to pick up. So definitely cloud and big data are two big items now. I just did this plot again of Google Trends just before coming to the meeting. And again, here we have in blue the cloud computing and in red the big data. And we see actually that big data has not caught up with cloud. So cloud computing is big, but, you know, trending down a little bit. And big data is actually, you know, having as much search traffic as cloud. So it's interesting to look at those two things. And as you guys are working, I'm sure your managers and directors, they're going to say, oh, what about big data? What about cloud? Do we have this solution? Do we have that? Another way to look at it is the hype cycle from Gartner. Gartner is an IT analyst company, and they released this hype cycle. So it looks like, you know, I don't know. It's not an S-curve of innovation, but what you see is that the first part of the curve that goes up very steep is called the technology trigger. So when new technology arrives, they're on the trigger. And then they plateau, you have the peak of expectation, and then they go down to the trough of disillusion. And then it takes years for technology to mature and reach productivity. So what we're seeing here is that actually, and again, that's a little bit dated, you know, 6 months maybe. You see that cloud, and I'm pointing at here in red here, the red circle, cloud platforms are actually almost at the disillusioned state. Okay, so people got very excited, and now they are totally disillusioned. Great. But if you look at big data here in red, in green, I'm pointing at the green circle here. You see that big data is totally in the trigger, so big data is big. Okay. It's a little bit surprising to me actually, because if you look at the history of all the software, the software that are involved, the Google file system, the first paper and only paper actually on Google file system was from 2003. So it's 10 years ago. Okay, so big data actually started 10 years ago. Hadoop, that came from Facebook, actually came in 2005. Okay. Hadoop enters the Apache Software Foundation, the incubator, in 2006. So that's 7 years ago. So that's, it's not new. The Amazon Web Service, simple storage service, S3. I don't know who uses S3 here. Yeah. So S3 was launched in 2006, and then they followed. Amazon followed suit with the Dynamo paper that describes a little bit of the software behind S3. So that's 2007. EMR, that's Elastic MapReduce. So that's when you are trying to analyze data with a big data backend like Hadoop. That was launched in 2009. And then CloudStack, here we go. CloudStack enters the Apache Software Foundation, or becomes a top-level project at ASF in just this year. And Provisioner here from Andre just entered the incubator in 2013. So it's kind of weird, because if you look at the history, all the big data work has been done almost 10 years ago, started 10 years ago. And cloud is much more recent, really started 2007. But yet, big data is now catching up, and cloud is actually going down. So it's a little bit of a strange situation, I find. I'm going to talk about big data because that's what I said in the abstract, but I'll try to go relatively quick about this. Big data, it's about very large-scale data sets, and if you think about Google and Amazon, what the problem these guys had, okay, is that they were basically downloading the internet, downloading all, tons of data, and they had to deal with how to handle those very large-scale data sets. Not only web, the logs from their web application, health records, instruments. In Switzerland, we have the Large Hadron Collider that collides all those particles, so that generates, petabytes. But it's not only large data, it's also very complex data, and I'm sure the guys at Adobe here, they know how, to deal with complex data, not necessarily big, but actually complex, unstructured. One of the examples that I like is the IBM Watson supercomputer. So it was 2 years ago, I think. It played Jeopardy, the game Jeopardy in the U.S., and it won. And there was a big cluster in the back end of that system. It was like 5 racks, I think, of IBM servers. But the actual data set used for Watson was only 100 gigabytes. So it was not big data, per se, but it was complex data, unstructured text, and basically trying to mine that in real time to figure out the questions to the answers, right? And in fact, big data is really a natural evolution of the file system and the databases. So, file system started, and then people said, hey, let's add more machines. We create a parallel virtual file system, and then we have databases. And the evolution really has meant that the distributed file systems are now being called, they're different, but they're now being called object stores. So we talk about, Hadoop being some kind of an object store. React CS from a company in the US called Basho is a big one. S3, Gluster FS, things like this. And the databases have seen all that movement with NoSQL databases. So we know Redis, the key value stores, MongoDB, CouchDB, all of those. So we've seen kind of like that natural evolution. And the way that has happened is really that if you look at the semantics of what those object stores are trying to achieve, it's different than the distributed file system. The very large object store like Hadoop, they're usually write once and then read many times to mine the data, which is a totally different scenario than the file system that, when people were doing research on file system, they realized very quickly that, scaling it, is a real nightmare. So really, it's a natural evolution. And there are different things with big data. Usually, we say big data equals Hadoop and equals MapReduce, and people get confused. MapReduce is just an algorithm for parallel processing. Okay, so you can do it on your own computer, you can do it in Python, you can do it in Java, you name it. And then HDFS, the Hadoop file system, it's not MapReduce. MapReduce is a project within the Hadoop top-level project at the SF, but they're not equal. And big data is yet, it's not equal to any of those two, but really a mixture of things. The bottom line is that we have more and more data, and we want to analyze that data, of course. So now, what about CloudStack? So I've already mentioned a couple of times the Apache Software Foundation. What's happening is that Hadoop, the really granddaddy of big data, is a project at the Apache Software Foundation, and now CloudStack is at the Apache Software Foundation, and they are all Java applications. Okay, so Hadoop is Java, CloudStack is a Java application. So I was thinking, well, they're under the same open source umbrella, and they're all using the same language. There has to be some type of a connection there, and as we see with the trends, they're becoming as famous, both of them, cloud and big data. So, how do they relate? How do cloud and big data relate? So now CloudStack, if you think about CloudStack, it's basically an application, a Java application to do infrastructure as a service. Okay, so if you've heard about cloud, it's basically software as a service, platform as a service, and then, Azure, and then infrastructure as a service. An example of infrastructure as a service is EC2. Okay, so EC2 was the first, public cloud, and definitely Amazon is a big, is the leading innovator in clouds with all the services that they offer with AWS. What happened is that when EC2 came out, people got very excited, and then people started trying to write applications to emulate EC2. Okay, so CloudStack, in some sense, is an EC2, Amazon EC2 clone. Okay, except that Amazon didn't release their software. We don't know how they're doing it. But if you take CloudStack, you deploy CloudStack on your infrastructure at your company, and then now you're going to have a cloud that looks like Amazon EC2. Of course, there are other players out there in the cloud infrastructure service domain. You probably have heard about OpenStack. It's a big player out there that makes a lot of noise. Eucalyptus, I'm pointing out here, in green with the green leaves. That's actually the first EC2 clone that came out of University of California, Santa Barbara. That was 2006. Open Nebula is the only European project from Spain, University of Madrid, same thing, 2006 and so on, 2007. Overt is from Red Hat. Ganeti is actually a new project. It's all Python coming out of Google. Open Nebula is C++ with some Ruby front end and some Bash scripts to do all the systems work. OpenStack and Ganeti are mostly Python and most likely some Bash in there. And then CloudStack, is a Java application, Tomcat web server, Axis web services, you name it. Yeah. You have to speak in the mic, otherwise you're gonna get mad over there.
Okay, so Rackspace, HP Cloud,
So those are public clouds. Those are companies that offer a service, infrastructure as a service, just like Amazon EC2. And they run a version of OpenStack. So that's what we're looking at with CloudStack, basically a Java application to build an infrastructure as a service. And really what it is, it's an application to manage your data center. So manage your servers, manage your storage, manage your network, and that application needs to be able to handle failure, handle very large scale, and CloudStack, all the data structures and the queuing system inside CloudStack has been optimized so that it can, deal with 10,000, 20,000 servers. So Citrix actually has customers that have 300,000 cores under management with CloudStack. So that's quite a bit. And the big aspect, for me, for clouds is that they're programmable. I like to use that word, programmable, because, most of you, I guess, are programmers. And, you need to be able to program the data center. That means writing code that, create machines, stops machine, moves them from, one data center to another one, move data, create network. Everything can be done, at the application layer because those systems and CloudStack in particular expose a very rich API. Okay, there are over 300 classes that are exposed by CloudStack, Java classes, and you can use that to manage your data center. So, if you need to remember something about what is CloudStack, it's a programmable data center orchestrator. So a Java application that allows you to, manage your data center. A key aspect of cloud is virtualization. So in your clouds, you can manage physical machines, but you're definitely managing virtual machines. And to create virtual machines, you need a hypervisor. Okay, that's where, he mentioned Zen. There's KVM, VMware. All those are hypervisors, and CloudStack can deal with all those hypervisors. We're actually developing a CloudStack developer is working on a Hyper-V plugin, from Microsoft, so we'll have Hyper-V in there as well. It programs also the storage, so we can use all sorts of different storage. If you guys are into storage, you may have heard about Ceph, React CS, you name it. And then we can do all sorts of, networking things, VPN, virtual private cloud, load balancer, firewall. We can do all of those things with the application. So that makes CloudStack a pretty big package, over 1 million lines of code, if lines of code mean anything. But it's a pretty big package to be able to program your data center. CloudStack came as a startup, VMOps, in 2008. They open sourced the software, and then the company was acquired by Citrix in 2011. As part of the acquisition strategy, they thought that they needed to put it in the Apache Software Foundation, and I'm going to talk about that a little bit more. And CloudStack was made a top-level project in March this year. So now we are, full-fledged Apache project. So, why the SF? And we saw Camel, in the previous presentation, which is, also an Apache project. Well, SF is definitely the most well-known open source software foundation out there. And really the idea is that around an open source, system, you build a community. So you have developers from different companies that can access the source code and can, contribute plugins and patches, documentation, you name it. So everybody can jump in and actually create, a nice ecosystem around CloudStack. And also companies can, basically build products around CloudStack. So definitely, we all need a paycheck. So, companies actually integrate with CloudStack and they sell their product. One big aspect with ASF is that the processes to contribute, to submit patches, to be part of the project, to have a say in how the project evolves and things like this, all these are as very clear processes. So that was a good move to go to the Apache Software Foundation. So here that's a graph just to give you an idea of the size of the community of that application, just so that you don't think that it's a small package with like 3 developers. Over time here, and the x-axis, you have the number of developers in the community. So you see that in April we reach roughly 200 contributors on both the developer side and the user side. Okay. In terms of companies at DSF, we cannot really talk about companies. When you participate in the project, you're an individual, you're not representing a company. But we can still look at the email domains, from the mailing list and get an idea of how many companies are involved. So what we're seeing here is that as an accumulation, I'm pointing at the top right corner. And the reason I'm saying this is because he asked me to say it when I'm pointing. So here I'm pointing at the red line. It says, roughly 250 companies. Some of them are the same on the users and the developer mailing list, but roughly you have, 450 companies involved in CloudStack development. So that's or development or use of CloudStack. So that's a pretty big package. Some of the people involved, Sandgard, Schubert, Phyllis, and A lot of those are actually European companies. Schubert Phillips is in Amsterdam. LeaseWeb is based in Amsterdam. I mean, not that many, I guess. Citrix is worldwide. React.cs is a small booming startup in Silicon Valley. They do an object store, big data, and so on. So the link that I'm seeing with cloud and big data is that everything is happening at the Apache Software Foundation, ASF. We have CloudStack, as I mentioned, but Hadoop, the big data storage system is at DSF. HBase, which is built on top of Hadoop, is at DSF. Delta Cloud, which is, I'll mention it, but it's basically an API wrapper for all those cloud systems. It's at DSF. CouchDB, Maven. I mean, of course, you recognize all the build system and Maven, the web server. So what we're seeing is that more and more of the big data and cloud packages are actually within the Apache Software Foundation. I just had a look at it the other day, and if you look at the incubator of Apache, so new software that's being put into the SF, there are 35 projects right now in incubation at the SF, and 11 are big data related. So that's 30% of the incubator is actually about big data. Okay. A new one that joined the incubator is JCloud, and JCloud is Java for clouds. So it's a Java, application that basically builds a wrapper for all those cloud APIs. So I mentioned CloudStack, OpenStack, OpenNebula. All these expose different APIs, and we won't go into standardization discussion here. But what JCloud and Delta Cloud also, but what JCloud does is basically, it's a wrapper to talk to all those different APIs, and it's also in Java. So it's a good place to get involved. It just entered incubation. And Provisioner, of course, from Andre is also in the incubation. The top level, 116 projects, 14 are cloud or big data. So that's, at least 10% of DSF is cloud and big data. And I already mentioned a lot of those packages there. The entire Hadoop ecosystem, the entire big data ecosystem is at DSF. So now, you're thinking, okay, big data is at DSF, CloudStack is at DSF, so, how do the two actually merge and talk to each other? Well, what's happening is that, I mentioned CloudStack manages your data center, and most likely in your data center at one point you're going to have a big data storage system, okay? So CloudStack is going to have to deal with that big data system, or it's going to have to make use of it, okay? So what we're seeing, okay, is that CloudStack can use a big data solution. So you use a big data implementation as a storage backend, or the other way to actually merge CloudStack and big data is that in your cloud you're going to deploy a big data infrastructure to do data processing. So let's say you work at Adobe and you collect all those data from PDF. I haven't looked at Adobe in a long time, or the Adobe Connect data stream. You put all of that in a Hadoop cluster that you deployed in the cloud, and now you have some data analysis that you've expressed in a MapReduce framework. You run all of that in the cloud, and you get everything back. So that's the second view of things, is to look at big data as really a workload of your cloud, okay? So how can you deploy a big data solution in CloudStack? So big data as a backend, we have lots of storage backends going on here. We have OpenStack Swift, Caringo, Object Store, Ceph, which is a really big, it's an object store that has lots of traction. You mentioned that it's CephFS. It also has a file system, but it can be used. Most people use it as actually as an object store. Gluster, React.cs, and all of those actually expose the S3 API. I don't think I'm wrong. No, I haven't checked myself, but I think all of these guys expose the S3 compatible API, so just like Amazon, okay? So you have all those that can be used as a backend to CloudStack. Now, an interesting thing in CloudStack, as I mentioned, is that mostly it's going to manage virtual machines. Okay, that's one of the big features of the cloud. That's how you you give all those services on demand because you can create servers on demand. But right now, we're also going to support bare metal, which means that we're going to be able to manage physical servers, okay? And that's going to come in the 4.2 release this summer. So that means that if you want to deploy a big data store on physical machines, okay, you're going to be able to use CloudStack bare metal facility capability to do that, that deployment. I'm trying to go a little bit faster here so that I can show you a demo, because otherwise you won't believe that CloudStack actually exists. But anyway, so CloudStack has a management server, Tomcat, Axis Web Services, a MySQL database, exposes all the API, and then basically you define data centers or zones. So imagine a data center with a bunch of machines racked together. So you define zones, and in those zones you have a set of hypervisors, so servers that run Xen or KVM or VMware. And we also have something we call the secondary storage, and here I'm pointing at the secondary storage. And that's where you put all your images of virtual machines. You need an image catalog, so you put all of them on that storage. And that storage can be, you know, an object store. That storage can be a big data store. So that's the typical use case. Now, if you move beyond, and you know, I understand you guys are you know, most likely you know, Java developers and not infrastructure people. I don't know who deals with infrastructure here. Okay, 2 people. Okay, 3, 4. Okay. So you can start mixing now with the fact that in CloudStack you can do bare metal. You can start mixing in your zone. You can have machines that you're going to use to create virtual machines. You're going to have that storage that contains those images. And now you have those bare metal machines that you're going to use for that big data system. If you want, you can move further and actually remove that secondary storage, maybe using NFS, and just build an entire secondary storage on bare metal with a big data solution. And finally, if you really don't care about compute, you know, processing, and what you want to expose or manage is just storage, then, you know, just in your zone, just manage a bare metal big data cluster. Okay. So those are some of the configuration that you could have, and of course any combinations thereof. And one thing that I find interesting is that since it's all programmable, okay, you could scratch everything and reconfigure everything. Of course, you don't want to scratch your data, okay, but you can imagine a reconfigurable architecture depending on the workload that you have, depending on what's hitting or using your infrastructure. You can just reconfigure your entire data center. You know, you need more compute, just grab some nodes from the storage, if, you know, it's replicated and so on. Grab some nodes, create more compute. You need more storage, just, you know, consolidate the compute. So now, the second thing is actually big data as a workload to the cloud. And here I say tools and demo. I'm just going to do the tools because I just downloaded some of the new demo before coming, and of course the trunk doesn't work, so there is no demo. But basically here the idea, as I said, is okay, you want a big data infrastructure, you want that Hadoop cluster to do MapReduce, and you want to deploy that on demand in the cloud. So what tools are out there? There's one big tool in Apache, it's called Apache Weir. Some guys from Cloudera, Hortonworks probably, and then I think you're a committer on Weir, right? So some, you know, some big guys in big data have developed that package, Weir, and you know, you install Weir on your machine, you write configuration file for a big data infrastructure, you just launch that script, it hits a cloud, and it deploys the machine properly, configures them with the software, and then you have that big data system. It's not as simple as, as I just made it to be, because you know, not all the clouds expose the same capabilities and have the same configuration, so there can be some issues. One of the key players of all the system, as I mentioned, is JCloud, Java, you know, for clouds. So that's that wrapper for all the cloud providers. So Apache Weir uses JCloud. Here's a Weir configuration file. just to give you an idea of what you're doing. So you're trying to, you know, giving a name to that cluster of machine. You're saying, okay, I want one machine here to do the master node, and then here I want also one data node. So if you really want big data, just put one, and then just put 1,000 here, maybe 10,000, and then you have something much bigger. Provider here, you see that we can actually use CloudStack. Okay, so you're going to actually talk to a CloudStack cloud to make that deployment. Pass your keys. Here, that's the Cloudera distribution of Hadoop. Okay, so that's that big data system. And here, you define that endpoint. That's a CloudStack endpoint. Okay, that's CloudStack running, exposing the API here at that endpoint, and then some image ID and things like this. So that's a configuration file. I should have removed that. Okay. There are other tools out there that actually derive from Weir. Brooklyn is one that you should look at. Apache Provisioner, is in incubation, definitely interesting. I'm looking at something these days that's called Knife CloudStack. It's not Java, it's Ruby. Knife is it's a tool to configure machines, okay, using Chef. Chef is a configuration management system. And what's interesting that I didn't know in Knife, and I only realized that like 2 days ago, is that in Knife you can define basically a cluster of machines. So you can say, I need one machine that has this role, I need two machines that have this role, deploy this machine, and then at the end do this action, okay? So you're defining a graph and basically some very basic orchestration when you're deploying machines, okay? So that's very nice to be able to deploy a cluster of machines. StackMate, it's also in Ruby. It just got started like a month ago from a developer from CloudStack. And the idea is to basically emulate CloudFormation from Amazon Web Services. Does the same thing. Basically, you're going to write a template that describes your big data infrastructure. Once you have that template, just give it to StackMate, and StackMate is going to provision everything that you define. Palette is nice. I haven't had time to look at it, but I'm mentioning it because it's written in Clojure. So all the Java guys will be fairly happy. If I'm saying this right, it's a dynamic programming language compiled for the JVM, and much easier, at least to me, to understand and write than Java. Okay, but it's written in Clojure, so it's pretty good. It's totally different from Weir. There's no link. It's not using JClouds. So that's something to look at if you guys are interested in Clojure. And the reason I'm interested is because there's a guy living down the street from me who's written a Clojure client for CloudStack. So if you want to talk to that CloudStack API and you want to do it in Clojure, there's a client for that written by Pierre-Yves Richard. So, look it up, CloudStack. Who has looked at Clojure here? Yeah? So Clojure is also interesting because it's not only about Hadoop. Big data is not only about Hadoop. It's also about real-time data streaming. So Storm is a system. So I think it was created at Twitter, right? No? It was created by a company that Twitter bought. Okay. Just like what you said, Zen was not created by Citrix. Citrix acquired Zen, but anyway. So Storm, interesting. It creates basically a cluster of machines that are going to receive real-time streaming of data, and then do analysis on it. And what's interesting, there's a package called Storm Deploy, and it's written in Clojure, right? Yeah. So that's why I'm going with that, and a lot of it is actually me doing a little bit of investigation here. But all the Clojure aspect is because of Storm that I find interesting, being able to deploy on demand, deploy a real-time data processing system. So current development for CloudStack and big data. So we're looking more and more into integrating Hadoop as a backend to CloudStack for the management of the storage of the machines and so on, and also to be able to expose an elastic MapReduce API. Amazon has this, which is basically instead of saying, okay, start that many machines so that I can use it as a storage engine and then I'm going to do my processing, they expose directly the processing system, which is you define the scripts that you want to run, you define your input data, you define where you want to output the data, and EMR takes everything and creates the instances in the backend. You don't have to do it; it does everything. It does everything for you. There is another interesting thing going on is that Basho, the company doing the React CS, the object store, they open sourced their object store very recently, and they integrated it with CloudStack, but they have a MapReduce implementation. So I wouldn't be surprised to see some type of an EMR service within CloudStack coming via the Basho integration. Interesting thing, and maybe some of you can relay that to students to keep an eye on, is the Google Summer of Code. So being part of the Apache Software Foundation, we basically submitted potential projects to the Google Summer of Code, and we were very lucky to have 5 very strong proposals from students: Ireland, Vietnam, India, Florida, and somewhere else, escapes me. And 2 of those projects, one project is actually to improve the CloudStack support in Weir and Provisioner as well, which are those big data, provisioning systems that I talked about. And the other project is also to have better CloudStack support in Mesos. Mesos is a new project. It's in incubation at the Apache Software Foundation. It's a derivative of what Google is using to do all their parallel processing, or it's supposed to be close to what Google is using. So, if you want to keep an eye on CloudStack, cloudstack.org, you got it on your T-shirts, you got it on your USB keys. Follow us on Twitter. All the slides, I put them on SlideShare if you want them. I also put lots of interesting, or at least introductory screencasts for CloudStack on YouTube. If you actually want to, look at the code and see how it works, look at those screencasts, and then join the mailing list to contribute. We need lots of developers, can help us with Maven packaging and unit testing and Spring. We just put Spring in the 4.1 release that's coming up next week. So we need experts in that front. Oh, I went fast. No? Too fast? So let me just show you something, because Eugene was like, they have no clue what you're talking about. Okay. So let's look at CloudStack. To look at it, I have a virtual machines running here in VirtualBox. That virtual machines contains CloudStack. It's Zen. It's an Ubuntu machine, Zen hypervisor. So it contains everything, the MySQL database, the Tomcat, and everything. So I just ran it, okay? I just started the machine. Can you read this, or should I make it bigger? A little bit bigger? Okay. If I log into that machine, so I'm on that virtual machine here. If you don't know Zen, that's a Zen command here, VM list. So what you see here is that we have 3 virtual machines running. The control domain, which is called DOM0, that's the base hypervisor. And then we have 2 other VMs running here, V2 VM and then S1 VM. So inside that VirtualBox instance, I have 2 virtual machines running plus what's called DOM0, okay? But what's interesting with that sandbox is that CloudStack has started automatically. There's port forwarding set up, so if I just go to localhost 8080, so that's my laptop, but that's forwarded to the VM, I get on the CloudStack interface, the web interface. Yes, that always happens. I'm actually coordinating the translation of the documentation and the UI. Okay, and we have lots of translators out there. We have like 40 translators that have done like Russian and Japanese, Chinese, and so on. I don't think we have Romanian. Okay, we use a website called Transifex. So if you go to transifex.net, it's free, and then you access the CloudStack UI project, and then you can translate like word by word. So Sunday night you don't know what you want to do, and it just translate 10 words. That would be great. So anyway, so this one is in English. The translation is not working on that one. So anyway, so that's the dashboard. So what you see on there, I can manage accounts. It's all JavaScript. So here I see my users. I only have, okay, fine, I have 2 users. Here what's interesting is that you see keys. So here I have an API key and I have a secret key. It's a basic authentication mechanism for all of the clouds out there. You always have API key and secret key. You have templates, which is an image catalog. I was mentioning that storage engine that has all the images. So that's here in that template, and you see here I have 2 templates. Those templates are for the Zen server hypervisor because I'm running Zen here. Storage, those are disk systems that are stored in there. So if I had 100,000 VMs, I would see 100,000 disks in there. And then if on those VMs I take snapshots, I would see snapshots. So I would click here actually, and I would see, okay, fine, I took snapshots. So I see snapshots. So those are actually data volumes that I've snapshotted a virtual machine to basically make a backup. If I click on instances, I see that okay, all the instances here are stopped. And now we go to the infrastructure. So we see that I have one zone. So I'm managing one data center. Inside that one data center, I basically have one rack. Inside there's one cluster and there's one host. It's kind of a silly example. That's because everything is running on my MacBook Air here in that VirtualBox setup. You see that I have that storage, the storage backends defined. And what I was mentioning as big data is that secondary storage here could be a big data store, like Gluster, Ceph, and so on. Ceph can actually also be used as primary storage. System VMs are little virtual machines. Those are the 2 virtual machines that I show you that are running. And they are running in that system to help doing the orchestration, so help manage the disk images, the volumes, and so on, and also give you a reverse VNC connection to the virtual machines. So you go here. Okay. Okay. Let me hit that again. Okay, fine. Here you see the basic API. So it's a HTTP call. It's not a REST. It's very much a basic query API. So you pass the command name. So here you see list virtual machines. I'm pointing at the Firebug debug console. So you see list virtual machines. So there is a list virtual machines class, and then you pass all the parameters. Most interesting here, list all equals true, and you're asking for a response in JSON format. So every time you go through the UI, you'll be able to explore the API, and you see that the API is, but here it has a session key. There's a signature that's computed with that secret key and so on. So I guess if you guys are doing web applications, you understand all of that. If we want to start a VM here, I only have one zone template. I'm saying, yes, I want to start a tiny Linux VM. Tiny offering is basically the amount of RAM and the amount of CPU I want. So here I want something super small so that it may have a chance to start. I don't want it to attach any disks because it's all on my laptop. I don't have any space. Network, anyway, launch. So now I've created the VM. You see all the APIs here that I've gone through. So list disk offering, list network, list security groups, deploy virtual machines. Here was the call that was done to actually do the deploy. A deploy virtual machine is an asynchronous job. So you see that now the system is going through a query asynchronous job result. It's passing the job ID, okay, and you see that it's it's keeping on churning here. So now if we look at that one again, what you're seeing here, again, is that Zen that Zen hypervisor when I'm running the VM list. Ah, here you go. Well, so you see that now instead of 3, I have 5. So DOM0, and then I have the V2 and the S1, which are that storage system and that console system. I have another one that started, which is the R, the virtual router. That's a little virtual machines running in there that handles all the networking. So that's what that one is doing. And then you see that I have this one that started, which is the instance, and the instance is running. So you see system was faster than me switching screen. And you see now that I have the virtual machines are started, it's in running state. So now I have a running virtual machines, I can SSH into it, I can set up any software I want, and so on. So now imagine that instead of doing that very silly example, you're actually hitting a real data center with okay, let's go crazy, 10,000 physical machines, and you can start 100,000 VMs, and now you're deploying your big data solution on there. You can do a lot of processing, okay? One last thing I wanted to show you, if you want to explore the API, well, actually, that's not gonna. We have an interactive shell, CloudMonkey, and I don't know if that's gonna work, but yeah, okay, fine. I said that CloudStack has a very rich API, maybe over 300 methods available. So here you see I type list, and I see all the list APIs available. So list users, oh yeah, okay, it worked. I'm actually using a real cloud here. That's why it's happening. You can put filters, email, username, there you go. Oh yeah, that's a real cloud in Paris. Okay. So you have this, so you want to do list templates. That's if you don't like the GUI, okay? Okay. So you have a tabularized output. You can filter with keys. So you have a very nice shell. And every time here you type, you do tab space. You do tab. Well, okay, you only have one here. Do help. You have the docstring documentation of that call. You see that it's an asynchronous call. You have all the parameters you can type, pass, and so on. So if you're trying to explore the API that's deployed, it's a very nice system. Okay. I think that's it. Thank you very much. And I know I didn't show too much Java, but hopefully it was interesting. And thank you very much. Questions? At least one question.
So who's the guy who's working on provisioner for CloudStack?
Her name is Meng Han from Florida.
Okay.
PhD student from University of Florida.
She wants to work also on Weir and provisioner, or?
Yeah.
Good
part
luck.
of the project. I mean, she's gonna look at Weir, but she hasn't started. So I started looking at Weir, and we're trying to fix a bug with Andrew. But if Weir, works, I think she's gonna have a look at provisioner.
Okay. Thanks.
Yeah, no problem. The Google Summer of Code was just announced Monday, so
this is more like a general discussion. what do you think about building an object store? Why not build that on top of the compute infrastructure? Why deploy like different infrastructure altogether? And let CloudStack manage like the object store so on top of the compute infrastructure.
I'm not sure I understand the question.
So let's say we want like an S3 system.
Yeah.
We want to deploy React.js.
Yeah.
Why not design the deployment system for React.js to make use of the compute infrastructure that's already there?
So you want to mix data and compute, right?
Yeah, because the machines have local storage. Why not use local storage for the blob store?
I mean, I think, you could. I mean, theoretically you can. So you want to mix, you want to be able to use the machines to do VMs and use the storage to do the object store. Technically you can, but I think right now in CloudStack you may have a problem that one host cannot be in two zones. So I think that would need to be decoupled. But yeah.
Because the answer I got most of the time was that it's not a good idea to mix workloads like this, because you may not have the right machines to design an object store. You may have like generic machines designed to run a large number of VMs.
You would have to ask, I think, a data center guy to exactly know, the specific requirements of the workload. I mean, from what I see or what I know is that definitely, people right now in data centers they study really hard what's the workload that they have to run, and they design not only the data center but even the hardware, especially for that workload. So, for example, like gaming companies, some of them actually go from they leave behind virtual machines and they go bare metal. So they use bare metal of CloudStack because they have very customized hardware for their workload.
Customized network and everything.
Yeah, and they know they can actually customize that hardware better than, they can use that hardware much better than consolidating with virtual machines. What you would obtain that type of consolidation. So if you start mixing, I'm sure we're gonna see it, but the question is that type of setup going to be used really?
There are some advantages in mixing, like you can deploy then the compute side, like having HDFS and deploying like the MapReduce layer on top of the same machines to get data locality out of cloud.
Well, that was really the promise of Hadoop, right? Is that you had the data locality, so you knew where the data was, on which machine it was, so that when you were parallelizing your work, it would go to those machines where the data was, so that you would have reduced latency or I/O latency. But I think that in fact it's the data locality is actually not used, or not well. That's what I've heard.
It's not used in most of the cloud deployments right now. I mean, with EMR, it doesn't work.
Yeah. So basically, you have the storage there, and then the processing, happens somewhere else, and the data is actually.
Yeah, I mean, this is a different discussion. Data locality is still useful, but for intermediate data.
Yeah. But that was the promise of Hadoop to, or that was one of the big use case of saying, let's take advantage of data locality so that you actually put the computation where the data is.
How long would it take, let's say, to install CloudStack on, let's say, 10 machines bare metal that don't have anything? So on the bare metal, it's just like that, or it has to have some Linux installed before?
I run CloudStack on my machine, not in DevCloud, but basically, if you clone if you want to do it from source, you clone the repository. It's just a Maven, install Maven command to configure the database, and then you run you could even run it Maven to run JT or something like that. That's super easy. Okay.
So in theory, you just need the image. Let's say the VM image for the machine. So how do you want the machine
to run the management server? It's probably a 30-minute deal. Okay. What's going to be more challenging is actually to configure the entire data center. Okay. So you have those 10 machines, but yeah, what's your network environment? Okay. Are you using VLANs? Do you have a single IP subnet? Things like this. So you need to know what's the architecture of that system. If you go in there and then you suddenly say, oh yeah, I'm gonna use VLANs, but that you don't have your VLANs configured and so on, you could get into a mess. Okay, but if you know what you're doing, which is always difficult when you start, you could deploy CloudStack on 10 machines in I would say an afternoon. Typically, run, take one node, MySQL, Tomcat, build. You can get the packages if you want. Launch the management server. That's easy. You have the machines. Choose your hypervisor, Zen, KVM. So install that. Add the agent, the CloudStack agent in the case of KVM, and then basically now you can register them in the management server. You need a shared storage system. So if you want to go quick and dirty, just set up NFS on one of those machines. Export NFS on all of them. You have your system, and then for the primary storage, use local disk. Okay, so if you do that, no VLANs. That's what we call basic networking, and that's easy.
Okay, thanks.
Yep.
Any more questions? Well, thank you. I made a reservation to a local something.